Okay, students, very much happy to meet you all of you here on this wonderful day. And I do want to take in the discrete mathematics Boolean forms. There are two types of Boolean forms. One is called the sum of products, and another one is called the product of sums. Here, sum means join, and product means meet. So, sum of product means join of meet and the meet of join. There are two types of forms in Boolean algebra. Okay, the Boolean forms we talk about. So both the forms we will take now and express that. Okay, now look at this Boolean forms here. Okay, so now what is a Boolean form first? So Boolean forms is nothing but there are two types of Boolean forms. One is called, I'll keep here, one form is called sum of product form and another is called the product of sum form. Okay, sum of product form and product of sum forms. Sum means what? Join, and the product we take as a meet. So join of meet forms. Another one is what we call product of sum forms. Product of sum forms. That means what? Meet of join forms. Meet of join forms. Okay. We know that what is meet and what is join. Am I correct? Now the meet is represented by like this, the star or asterisk we say, and join is represented like this. Okay, so look at this particular form. Okay, you see, look at this particular form. Sum of product means what? Join of meet. Look at this. The b of x is of the form here join of meet. Join of meet. Outside we have to come first, then afterwards inside this. So some expressions we can take here. Take for example here we can take A here, and we can take B here, and we can take here A dash, we can take here B dash, we can take here A star B dash. So you must understand that this is a good example for sum of products. Sum of products, that is join of meets. Okay, so outside join will come there, inside meet will become there. This is a good example for sum of products form. And this is another example given here. B of x equals x1 meet x2 join x2 meet x3 complement join x1 meet x2. This is another example for sum of product form. Okay, right. Now what is the product of sum form? Product of sum form goes like this. As I told you that it is a product of sums. Product of sums. Okay, the product of sum means what? Meet of join. Meet of join. A good example is given here. Note that. It's a wonderful example there. Am I correct? Look at this. B of x equals x1 join x2 complement meet x2 join x1 complement meet x2 join x3. This is a good example for product of sum. That means what? Meet of what can I say that? Meet of join. We can say meet of join. Okay, that's what we have to understand. Now we will take some expression here, then afterwards we'll change that into a product of sum form or sum of product form. That means join of meet form or meet of join form. That we will be seeing now. Okay, so let us take example here. Now look at this example here. What is this? Now look at this one. First example, second example, third example. Okay, this is one Boolean expression we say. A Boolean expression is one where it consists of variables meet, join, complement, 0 or 1. If it consists of a mathematical expression consists of all these things, we call it as a Boolean expression. A Boolean expression. So this A, B, C are examples for mathematical expressions. Okay, right. Now we are going to change the given expression into a Boolean expression into sum of product form or product of sum form. Okay, I mean join of meet form or meet of join form. This is what we are going to see now. Okay, sometimes in the examination they may ask you, they will give you mathematical expression, I mean Boolean expression, and we have to write them in sum of product form or product of sum form. So such a problem that we are going to take now, and let us discuss about that. Okay, okay, get ready now. This is what given to us. Okay, now this is what given to us. The first expression is what? X1 meet X2. The second problem is X1 join X2. Third problem is X1 join X2 meet X3. Now we have to write all of them in product of sum form. Product of sum form, and we will take this particular problem now. Okay, that is X1 meet X2. How we can write this in product of sum form? Product of sum form. Sorry, this we can write as sum of product form. Sum of product form. How can we write that? We'll see here. Okay, right. Now look at this Boolean expression. X1 meet X2. How can we write this? X1 meet X2 meet X3 join X3 dash. You understand that here in the formula here, A join A dash is equal to 1. So in the place of 1, I am writing here. And we are applying this particular idea, A meet 1 is equal to A. So I am writing X1 meet X2 meet 1. Okay, that's what I am writing here. Okay, that is what I am writing here. You listen carefully here, and I am taking here. No, it is not clear. Okay, right, no problem at all. We'll take here, and other problem we'll express that. So X1 meet X2 meet 1 is equal to A itself. Now this 1 I am replacing by X3 plus X3 dash, some other variable, and its complement. Now I am doing the distributive property. X meet X1 meet X2 meet X3, that is coming here, join X1 meet X2 meet X3 complement. Okay, the distributive rule. This and this, this and this join comes here. Okay, so you'll get that what form we are getting here is the sum of products. I mean, join of meat. That's what we have here. Am I correct? And this form is called join of products. Join of meat. That's what we get there. Okay. Now let us take the second Boolean expression. The second Boolean expression is x1 join x2. x1 join x2. Now look at this here. This x1 join x2 can be written as x1 meet 1 because x1 meet 1 is x1 join x2 meet 1 x2 meet 1 because it is x2, so we'll get the same expression here. Now from this we can write it as x1. I am writing as it is, then the join of a variable with its complement. A variable with its complement with the meet will be equal to 1. Therefore, for the place of 1, I am writing this x2 meet x2 complement. Okay, similarly here, in the place of 1, I am writing x1 join x1 complement because 1 equals x1 join x1 complement. This x2 as it is. Now what I am doing there now, I am doing the distributive law. x1 meet x2. This join comes here. x1 meet x2 complement. This join is coming here. Now x2 meet x1 join x1. What's that? x2 meet x1 complement. That's what you are seeing here. Okay. Now look at this. x1 meet x2 is coming here. Okay, x1 meet x2 is coming here. x1 meet x2 dash is 1 and x2 meet x1 is coming here and x1 meet x2. Okay, that's what we see here. So this is 1. Other terms are coming as it is. So what we have here is that sum of products or join of meat. That's what we have here. So the given expression is x1 join x2, and that we have written as the sum of products of the Boolean variables. This is called what? Sum of products. Okay. So from this, what we understand is that mathematical expression, I mean Boolean expression, can be changed into product of sums and sum of products. So this way we are writing is called Boolean forms. Okay, this is the way we can write Boolean forms. We can write. Okay, now let us take other pages here, and we will be taking one more problems, and it will be going on like that. Now look at this third problem here. Third problem is x join x2, x join x2 and complement meet x3. Okay, so how can we write this? We can write like this. Okay, so now we'll take the other problem. This is problem 5. The product of some canonical form. Product of some canonical form. That means what? Product meet of join. Okay, so the time is over. We will see in the next class.